we can start taking the question from the participants who have already sent the question. Okay, so I'll go through one by one all the questions. So you can type in your questions in the chat box also. So once I have gone through the questions from the participants who have already sent me the questions, then I will go to the chat box. Okay. So anything you want to tell right away, any student or any participant? Nothing? Okay, so let me go to the questions one by one. Okay, so let me take the first question. Nilay Kalamkar. So is Nilay there? Nilay is not there. So let me take the next question then. Okay, Jai Surya S. Is Jai Surya S there? Okay, Jai Surya S is also not there. Okay, so let me download all the questions and maybe I will answer a few. Okay, so is Nitin there? Nitin Mehta? Is Lata there? So I think the students who have posted question, they are not here at this point of time. I will go to those questions later on. Okay, so is Akula there? Okay. Is Dipanshu Vashisht there? Yes. So let me take your question. So what is fault collapsing? Okay. So see, fault collapsing is basically trying to reduce the number of faults so that the test vectors can be more compact, right? That is the whole idea. But this is not the part of this this course. So I'll ask you to go to the references, the reference that I have given in the lectures. So go to that reference and learn on your own what is fault collapsing. Okay. Is it fine, Dipanshu?
Yes, sir.
Because to explain fault collapsing, I have to explain fault equivalence and fault dominance, which are again not part of this course, right? So without that, I cannot explain fault collapsing, and it will take at least 15-20 minutes to discuss what is fault collapsing. Okay, so let's not go into that, and you can go through the book by the references that I have given, right? So you will find that there what is fault collapsing. Okay. So let me go to the next question. Is Praful Bhuti there? Praful, no, she is not there. Is Dharma Samvartini? Dharma Samvartini? No, she is not there. Is HS Sanjay there? No, HS Sanjay is also not there. Okay. Is Mayur Patil there?
Yes, sir.
Okay, so let me take your question. So Mayur has asked how to get internship in physical domain, physical design domain. Okay, so Mayur, where are you studying right now?
Sir, I'm a MTech second year student in VIT Vellore.
Okay, so I think you should request the faculty members at your institute. That would be the best place to ask for the internship, because usually the internship are managed by the faculty, and they have positions in their group, right? So the best place will be your faculty, right?
Yes.
Other than that, will be that you can send your resume to various people, but typically that also do not get responded most of the time, right? People don't respond because they don't have the position, and they get so many
Yes, sir.
requests from the for internship, right? So that is also not very good. A better way will be through your seniors, right? If you know some seniors and your peers who are basically doing internship, you can give your resume to them, and that will be the second best option to go for internship. Okay. Okay, Bayur.
Yes,
Okay.
sir.
Okay. So is Bamshi Krishna there?
Yes, sir.
Okay. So let me take your question. So Bamshi, you are a working professional. Where are you working?
Sir, currently I was working in Siemens CD, sir.
Okay, great. Where in Noida, Bangalore, Hyderabad? Where?
Bangalore.
Bangalore.
Bangalore, sir.
Okay. So let me take your question. Yeah. What is the difference between cell delay and net delay? While calculating the cell delay, we consider the load value, and the load is nothing but the nets connected to it. This means we are also accounting for the net delay also. I have confusion in this. Can you please clear this doubt? Okay, so this is a very good question. So see, the what happens is that I have explained in my one of the lectures that for delay calculation, what we use is a stage. Okay. Now a stage consists of two parts. One is the cell and other is the net. Okay. And not only the net, the net which are driving the fan outs, the pins of the the pins which are being driven by those nets, those are also considered, meaning the fan out pins in the fan out. Okay. Now the when the delay calculation is done, it is the this structure, that complete structure, that is taken by the tool. That is one, say in inverter is a cell, right? And the nets in the fan out, and also the load that are being driven by that net, right? So this composite structure is known as the stage, and delay calculation is done for that composite stage. Okay. Now when you compute the delay, right, when you compute the delay for the stage, you take into account the NLDM model, if the delay model is NLDM, and then interconnect model may be simple RC model, it can be a capacitive model only, or it can be more complicated advanced model. There are like Elmore delay model, or and so on, and the pin loads, for which the model can be a simple capacitance, right, or the simple capacitor as the load, as treated as load, right? Now for this composite structure, the tool will do a delay calculation, and the delay will be from the input of the cell to the pin load that are driven, right? Now out of that, the tool will say that this much is the cell delay part and this much is the net delay part. So the delay calculation is done for the entire stage, and out of that, some portion is taken as the cell delay and some portion is taken as the net delay. Okay.
Okay. Okay.
Hope I answered your question.
Yes, sir. Sir, is it based on some algorithm, or
Yes.
do we
So
have
it
any
will.
physics behind it?
Yeah, so
How it will divide?
see, if there is a simple capacitive load, right? Suppose it is a capacitive load, there need not be any algorithm. It is simple, a kind of a delay calculation that you can get from query from the library. But if say it is a resistive load and there is an NLDM model, then there has to be some delay calculation, because NLDM model considers only the capacitive load, right? But your interconnect is resistive, right? In that case, the resistance needs to be accounted for using some algorithm. We are not going into those algorithm in this course, but those are iterative algorithm which converges to a solution, and that gives you a D, right?
Sir, one more thing.
Yes.
Sir, you mentioned something like base delay, right?
Yes.
So in the model files, library files, they have mentioned some values, right? That
Yes.
means they are the base delay values, right?
Right. Those are base delays.
Okay. So one more thing I have.
Yes.
So we are writing this exam now, sir. This will helpful in any this industry purpose? Will this certificate?
See, that depends on the company where you are going for an interview or so, right? See, knowledge is always good, right? Now, where it be helpful, I cannot predict, right?
Okay.
If you are say taking some other career route, then it will not be that much helpful. But if you are going into VLSI design, it will help you certainly, at least in the digital VLSI design.
Okay, sir. Okay. Thank you, sir.
Okay. So I think that's all. These were the questions that were asked over earlier, right? Meaning through the form that was shared, these questions were asked, and I have answered all. So now let me see if there are a few more students. Is Nilay there? Nilay Kalamkar? Is Jaysurya S there? Is Nitin Mehta there? Is Lata there? Is Akula there? Is Praful Bhuti there? Is Dharma Samvartini there? Is HS Sanjay there? Okay, so I have taken all the questions which were there from the participant who had already filled the form. Now let me take questions if there are any on the chat box. Okay, so I'm going to the chat box. Okay. So, sir, will this meet be recorded because I have exam in some time? So, MA, if you have any question, please ask, right? Please, Mega Satish, right? So, if you have a question, please ask before your exam. Okay, so I think she's not there. Now, Dhanush is asking, can you say how to design an inverter from RTL to chip? Okay. And how should we do that, sir? I need a guidance as the flow I need to taken care in each step, sir. Okay. So the flow that we have discussed is a kind of ASIC design flow. Okay. In ASIC design flow, it is assumed that you have standard cells and you have already designed an inverter, right? So how an inverter is designed, for example, using PMOS and CMOS, that is a separate part, right? That is a separate knowledge, or that is separate skill set which we have not covered in this course, right? So this course assumes that you have the libraries of inverter of logic gates such as inverters and so on. So those things are already present, right? Now, how to design those require separate study. So if you want, you can go into books by say Revi, and you can look into that how inverter is designed, right? So that is not covered in this course. Okay. Dhanush, is it fine? If you have any further question, you can ask.
Fine, sir. Thank you.
Okay. So Avinash has asked a question. Sir, I have done MSc in physics with electronics and specialization. Now I want to join the VLSI industry. Can you please shape the path, like how to start and what should I cover for entry level in front end job? See, what the first requirement, of course, is the skill set development, right? And I will suggest that don't get confined to front end, back end, or those things at this level. At entry level, I think you should be able to answer most of the questions in all the domains, right? So it is not good to confine yourself in your domain at a entry level in a particular domain like front end, back end, verification, layout, or so on. So at the entry level, as if you never know that where you will find a break, right? So you should be preparing for wherever you get an opportunity for an interview, you are able to crack that, right? So I will suggest that don't confine yourself to any particular domain at this point of time. Increase your skill set as much as possible, not only theoretical but also practical by running the tools, right? Now, if you have done MSc in physics, you must have a good background of devices, for example, transistors and so on. So I will suggest that build on that background, right? So build on that background, meaning that build on the concept of transistors, devices, physics, materials, which you already must have done in your MSc in physics with electronics, and take it as a base, right? So now if you want to find career in this area, then the career in devices, those will be more closer to you. Then you can also go into the analog domain where the concepts of devices are very much used, and also in the area of digital circuit design at the transistor level. For example, the concepts of how inverter is designed from the scratch, how spice simulations are done, and so on. So those areas will be a better fit for you if you have already done MSc in physics with electronics, rather than going for an entry level in front end job. Now, if you want that in particular, you want to go for a front end job only, then I will suggest that develop a very good background on Verilog, system Verilog, static timing analysis, and a little bit of verification, power analysis, and so on, right? So whatever was covered from lecture week 3 to week 8, I will say, that is very much relevant to you. And if you have time, also look into system Verilog. That will be helpful for front-end design. Okay. So if you are trying to go for an entry-level job, typically it looks like that you have a lot of things to study, right? But maintain your cool, right? Take things one at a step at a time. It is not that for career advice, you will see many people saying that do this course in 15 days, you will learn this thing. 1 month, you will do this thing, and so on. Don't go for those shortcuts. Those shortcuts will not help. Take a time horizon of at least 1 year. And in 1 year, try to build a background on digital, analog, devices, and many other areas which other interest you, right? So there is no shortcut to a VLSI getting a break in a VLSI design industry. It will take time. And the knowledge base takes say at least 1 year to build. And either you are in MTech, then you have 2 years at least, right? So that is a very good time to build a good background. 2 years is more than sufficient, right? If you are a BTech, then you have 4 years, right? Out of that, last 1 year you can devote on VLSI design, right? And if you have already done your BTech or MTech and you are not into academics right now, then take a time horizon of at least 1 year to get a good background of these things. and then you will be asset to an industry. And also try running these tools. Fortunately, we have some open source tools which you can run without the dependency of commercial licenses and other things. So you should take full advantages of those tools to run and gain knowledge on your own. For example, there are lots of simulators, Verilog simulators, which are freely available, right? So you should run program, simulate it, and see whether your program is giving you the expected output and so on, right? So you shouldn't wait for anyone else to give you guidance on this. A kickstart is given in this course, and beyond that, it is up to you how you take it forward and learn on your own. So most of the tools that are open source, you can install on your own machine and learn from them. Okay. So hope I have answered your question, Dhanush, right? No, sorry, Dhanush, who had asked this question? Avinash. Is it fine, Avinash? Are you there? Yes, Avinash is there.
Yes, sir. Thank you so much, sir.
Okay. Next question, Monica. Good afternoon, sir. How many weeks to learn track the exam, sir? I did not answer this. Sorry, I did not understand this question. Can you please ask verbally, Monica? What is your question? Monica Reddy, can you unmute yourself and ask the question? What do you want to ask? Okay, so let me go to the next question. Musharraf. Hello, sir. I'm currently working on ZCU111 RF SoC to implement quantum control system. I want to learn how to use hardware. Please guide me. Sir, are open lane, open road different? Okay. So I want to learn how to use hardware. This is a very big question, right? Please guide me. If you can see, this course is all about hardware, right? So if you have done this course, you have learned at least something about the hardware. Beyond that, what do you want guidance from me? I'm not sure. So Musharraf, can you unmute yourself and ask question?
So I actually I was in need of some sources where I can learn this from.
So see, over internet, there are lots of materials available as lectures, right? So you can look into various kinds of lectures, and whichever suits your see, hardware is a very big thing, right? Now, out of this hardware, what do you want? A digital hardware design, digital verification design, or analog circuit design. So what do you actually want? It will depend on that. You will look for resources.
Actually, there is an YouTube channel of IIIT regarding algorithms to architecture, in which there are few videos regarding ZCU111. So
Okay.
there are very few videos. So I would like to know someone whom I can contact or any sources so that I could.
You already
get in
have the
touch with
video. If you already have the video, then you should be able to learn from that video, right?
But
So
the content is very less.
so
There
you
are
can.
only 2 to 3
So
videos.
who is the person in that video?
I don't remember the name.
Okay, so please look into the name of the professor or the person who has given the or giving the lecture. By noting the name, you can on the website of IIIT faculty, you will find the list of an email ID of all the professors, right? So you can directly send email to the professor of IIIT Delhi who is running this course, and he will be will be able to guide you. Okay.
Sir, I have put 2 more questions in the chat. Can you?
So I'll go through one by one. Okay. So, sir, are open lane and open road different? So Jasmine, can you answer this question? Jasmine, are you there?
Yes, sir.
Sir, this question, whether open lane and open road are different.
Open road is made for physical design only, and open lane is for full flow RTL to GDS. We can go from RTL to GDS using open lane, but open road is only for physical design. These both are different tools, open source.
Okay, thank you very much. Okay, is it fine, Musharraf?
Sir, do we have open lane tutorial even in the further weeks?
We don't
No.
have. We will have only open road.
Okay,
Okay,
okay, sir.
so
There is one more question in the chat section.
I'll go through that. I'm going one by one through the chat. Okay. So Charan Raj Balne, I had a little doubt about signature analysis. So what is your question, Charan? Please ask.
Good afternoon, sir.
Good afternoon. Yes, please ask your question.
Sir, during the explanation about signal analysis, I mean, in the slides, you have explained that if the golden signature matches the test signature, then the circuit is assumed to be good.
Right.
And in the next sentence, desirable, I mean, what we desire is that signature of the good circuit and faulty circuit are different.
Right.
But if you compare the two sentences, if golden signature matches with test signatures, then the circuit assumed to be good. I mean, the two sentences are being different. It is not matching.
Did you go through the complete lecture?
Yes, sir.
Okay. Do you understand what is aliasing?
Yes, sir.
Can you explain what is aliasing?
It is like if the signature of the good circuit and faulty circuit match, then there will be a problem called aliasing.
Right. So see that these two sentences mean that ideally we want that good circuit and faulty circuit should give different signatures, right? But there can be aliasing. We cannot avoid that aliasing because we are doing a compaction. The information is being lost, right? So because of the information loss, sometimes it can happen that the good circuit and the faulty circuit are giving the same signature, which is not a correct thing, right? But it is unavoidable. But it is still okay if the probability of that aliasing is kept low, and that is what is achieved using LFSR. Okay.
Sir, but here we are saying that the good circuit, we are naming the circuit as good, says that it should be matched. I mean, the golden signature and test signature should be matched. We are saying that circuit as a good circuit.
Sorry?
I mean, when you said, I mean, in the lecture, you had said that when the good signature and the test signature, I mean, golden signature and test signature matches,
right?
We are saying a circuit as a good circuit.
Right.
But what we need is that we should not, I mean, they should be different.
Right. I mean, that is what ideally we want.
But how can we say, sir, it is a good circuit when they both matches? I mean,
so if both matches, then there is an aliasing. In that case, the best method of testing has failed, right? Do you get the point?
Yes, sir, but still there is something.
No, what is your question? See, the problem is that BIST is trying to reduce the hardware, right? You cannot have a very complicated hardware inside your circuit. Otherwise, the testing infrastructure itself is taking so much area that that it is not feasible, right? So you want to have test infrastructure such that it occupies a less area. Now, because of that constraint, what happens? Aliasing happens. And because of aliasing, what happens? This method sometimes can fail, right? It will not be able to differentiate between a good circuit and a faulty circuit, right? But this probability of this failure, if it can be less than, say, 10%, then it is still working, or it is a good method of working for 90% of the faults, right? It will be able to catch that problem, right? And that's why it is practically okay. Do you understand?
Okay, sir.
Okay.
Sir, add
Yes.
one more that I mean in
Let me take. Let me please write in the chat box. I'll take one by one. Okay.
Okay.
So next question is from. Let me see. Arjun. Respected sir, how can we design VLSI circuits that are resistant to radiation and other external environmental factors, right? So see, we are not covering these things in this course. If you want, there are references for those things. So typically what happens is that if you want to make radiation hard, then it is many things are done at the technology level. Technology meaning at the device level. For example, we used a special type of devices or transistors which are more radiation tolerant, right? And also we do for external environment, if you want to protect our circuit from external environment, we do shielding, right? We do shielding of circuits. We put our circuits around that. We have a metal ring or so, which will help us avoid external signal coming into our circuit, right? So since this is not a part of this course, I'll not go into further detail. There are references for that. If you ask question in the forum, I will point you to the references for this thing. Okay. Is it fine, Arjun?
Yes, thank you, sir.
Okay. Dipanshu Vashist is asking, okay, so exam pattern. Okay, so I was calling your name. You have asked Dipanshu earlier also. Okay, you're okay. So you asked question on fault collapsing, right? So exam pattern will be similar to what we have in the assignment, right? So the exams will be MCQ based, multiple choice questions, and you have to select one answer which is the most appropriate, right? So if you will have typically 4 choices, and out of that you have to select one choice which will be most correct, and you have to select that answer, right? So this will be the pattern. Any further question, Dipanshu?
No, sir.
Okay, so let's go to the next question. Lavanya is asking, Namaste, sir. Could you please explain the difference between library pin and instance pin? Okay, so see, libraries cells. So like you know what is a library? What library contains cell, right? For example, an inverter. Now, in a library, you will have different types of inverter, like inverter of size 1, size 2, 4, and so on, right? Now, the interface of that cell in that inverter cell, okay, suppose the name is INV1. So the input pin is that is known as the library pin, right? So that is the library pin. So the interface of the library cell is known as library pin. For example, if you have an inverter whose name is INV1 and it has got a pin A and as input and pin Z as the output, then the library pin is pin A and pin Z, right? So this is what library pin is. Now, when you make a design, for example, you have made a circuit, right? In that circuit, you will have lots of inverters. For example, you will have, say, 1,000 copies of inverter INV1X. Now, the instantiated thing that you have put inside your design, right? Now, you have a library. From your library, you pick one inverter, put it in your design, then pick the same inverter, put in your design. You can instantiate multiple times the same cell, right? So when the cell is put in our design, that cell is known as the instance, and the interface of that instance is known as the interface, sorry, the instance pin. Okay, so the difference is the abstraction level we are talking about. When we are talking about our design and you have pins, those are instance pins. If we are talking about library and the pins of the cells, those are known as library pins, right? So the objects we are talking about are at different levels. That is the difference. Okay. So is it fine, Lavanya?
Yes, sir. Understood,
Okay.
sir. Thank you, sir.
Okay, next question. What type of exam can we expect? Okay, so we have already looked into the exam pattern, right? Now, 3, sir, what path an undergraduate student should follow to settle in VLSI domain, right? So what I will suggest is that you should start concentrating from 3rd year itself, right? So in the 1st year, you should be looking, a BTech student should do the courses of VLSI related thing very, excuse me. So during the 1st year, a BTech student should do a very thoroughly take the courses, for example, digital circuits, right, which are taught in the 1st year, and also analog circuit, some integrated electronics and those things which are taught at the 1st year. So those are the basic things. You should be familiar with the concepts of circuits and also of amplifier and other things which are taught at the 1st year level itself, right? Op amp and how the op amps are biased, how digital circuits operate, what are say AND gate, OR gate, latches, flip-flops, multiplexers. Those things you should do in the 1st year. Then in the 2nd year, there will be more advanced courses related to integrated circuits. For example, you will have courses on devices, transistors. So you should do those courses thoroughly, right? Then the 3rd year is the most important part in a BTech curriculum. In the 3rd year, you should take courses on digital circuit design. For example, how inverters are designed, how NAND gates are designed, what is the dynamic circuit, what is a CMOS circuit. Those things you should be doing in your 3rd year, right? Then you should take courses such as VLSI design flow in your 3rd year, right? And also on something on analog electronics you should do in 3rd year, right? 4th year, you should contact your faculty member in your undergraduate curriculum for any project, right? So if there are projects, you should do those things. You should run the tools which are there, which are open source, which are freely available, and build a solid background in the areas of Verilog, system Verilog, and verification in the front end, and on the back end side, the layout and other things, right? So your 4th year should be more skill set oriented and tool oriented, right? So with this, what will happen is that at the end of 4th year, you will be, or 4 years of undergraduate curriculum, you will be able to be, or you will acquire sufficient skill set so that you can become a asset to the industry, right? And in the meantime, if you can get some internship, it will be really helpful. If you are not able to get internship, run the tools on your own, do your projects on your own. See, these are not very difficult things, right? There are lots of these days, there are lots of things on the YouTube and other things available which can help you to learn how to run the tools and do some project, right? Do simple project, right? For example, you can build a say adder circuit, right? A simple adder circuit, design it at the transistor level, do spice simulations, and then take some simple circuit, for example, a counter, synthesize it, see whether the behavior is correct or not, make a layout of it, right? So for these things, you may not need the help of an expert. You can do these things on your own. So that is what the purpose of this course was also, so that you get a head start into these things, and later on you can stand on your own feet, right? That is what is the most important thing. Other than the technical, the attributes which are important for in this domain is that you should have confidence, and these confidence will come only when you do these things on your own, right? Rather than taking help from everyone asking for, say, training institute for these things. It is better to learn these things on your own, right? And do projects on your own, right? And with time, you'll gain sufficient experience and skill set that you will become a good asset for the industry, and you can start giving interviews and those things, and will be gradually assimilated in the industry, right? So that is what I will think is a good path for an undergraduate student to settle in VLSI domain. Okay. So hope this answers your question 3.
Thank you, sir.
Okay. So now let's go to next question. Yashwant, what kind of project can we do so that we can gain more understanding? And can you share some projects which we can do for 3 tiers? Sorry. Let me read the question. For a 3-tier student. Okay. So the first thing is that don't be tired, right? Don't put yourself in a category that I am from a third 3-tier institute, or 2nd tier, or 1st tier. There is no tier, right? That is the first attitude change you should have. Don't think that you are of a 3-tier or any other tier, right? You should do it. If you should start doing projects on your own. What kind of projects? There are lots of projects. For example, take a simple circuit. Can you design an ALU, right? ALU is nothing but, or can you design a calculator, right? You give an input to it that I want 1 and 2 numbers, and I will give an operand, and it will produce me the correct output, right? For example, I give A as 22, B as 29, and give an operand as multiplication. Then will it produce at the output a value A in 22 into 23 or 29, right? Whatever the answer is. This is a simple example of an ALU. So why not you try to design it in Verilog? Make a Verilog design out of it, then do the simulation. Do the simulation and see whether you are getting the correct answer. If you are getting the correct answer, then synthesize it. Do the synthesis, right? Then you do the scan cell insertion. Then go to the backend. Take the same circuit. Say that this is my floor plan. The design starts with some arbitrary floor plan, right? And then try to do the placement. Whether you are able to do placement, routing, and those things. If you do these kind of things once, twice, thrice, see, there is no dearth of what projects you can do. Now, if you have designed a, say, ALU, why not add a controller, right? Once you have a controller, why not add a memory card, right? Once you have controller, ALU, and your and also memory, it is complete processing unit, right? Then go into adding instruction set to it, right? Make a CPU order, right? And so on. So there is no limit of the project, right? You can start with a small thing and then start making it them more complicated until you are satisfied that, okay, now let me go to some other project, right? So this is how you can start doing projects on your own. Okay. Is it fine, Yashwant?
Yes, sir.
Okay. So Musharraf. Okay. Sir, I found content of VLSI Revisited conducted by IIITD very useful for VLSI industry. Are there any recorded lectures available for those sessions? When will this course be offered again? So let me enlarge it because I cannot read the complete message. Okay. So Musharraf, some of the lectures are available, I think, but I think all of them are not available, right? So the lectures that I conducted, I think that are not available. But see, this VLSI Revisited course that we do at IIIT Delhi, that is a very fast-paced course, which is typically for the students who have already done these things at least once, right? For example, I cover the entire VLSI design flow RTL to GDS, which is covered in 12 weeks in this NPTEL course in just 4 days. Right? So we move at a very high speed, and we also skip some of the content, right? So in that sense, the courses that are on the NPTEL that are much more elaborate and easy to understand, right? But there are some lecture materials which might be available on YouTube. I am not aware of those things, right? So you can send question to Professor Anuj Grover of IIIT Delhi, who was organizing this VLSI Revisited course for last 2-3 years, right? He will be able to answer that question if there are some lectures available, recorded lectures available. Okay, is it fine, Musharraf?
Yes, sir.
Okay, now Shubhankar, you have said in introduction that this course will help in terms of jobs, skill set required there, and when we will apply for it. I'm not saying this is a job guarantee program, but based on skill sets, how to apply at my level. But can you guide us how to apply the industries which were shown in the description? I am graduate currently applying for jobs. I did BE and electrical engineering. Okay, Subhankar, so I'll suggest keep on applying, right? This course has nothing to do with application in any of the industry related industry. And if you expect that I will help you in this regard, then I think you are not correct, right? This is a wrong expectation from your side that I might help you in applying at in any of the companies that was mentioned. The companies that were mentioned in the introductory videos, the skill set will obviously be useful in that. But whether you are capable of that, how much you have grasped from the course, and whether you will be applied, it will depend on you, right? It will not depend on the course. So please keep applying, and all the best, right? If you have done well in this course, you have understood the concept, then you will find a break, right? Is it fine, Subhankar? Okay,
Yes,
so let me go to the next question.
Yes, sir.
Lavanya, could you please give me some information about current progress in the implementation of Moore's law? Right. So see, the people are not that current implementation of Moore's law. Moore's law is highly misunderstood concept, right? Moore's law is basically a prediction. He made a prediction in 1965, right? And it was not a physics-based prediction. It was more of an economical prediction, right? And it has been true, right? More or less, right? Over the years, more than 50 years, but there is no guarantee that it will be true always, right? It cannot be guaranteed. So all these companies, right? All these companies, for example, Intel and other fabrication related companies, for example, TSMC and so on, they are actually doing lots of experiments and developing new kinds of devices, which can be further miniaturized, right? And make the density of transistor much greater than what we have today, right? So all these companies, these advanced companies related to foundries, they are doing lots of research in this area, and they are coming up with new and new solutions every 2-3 years, right? So there are a lot of things that are being done in this area. I will suggest that go into the research papers in this domain and understand it. Okay. So this is not a part of this course, so I'll not take it further. If you want more information, then give a query in the forum. Then I will point you to some resources. Okay, is it fine, Lavanya?
Yes, sir. Thank you, sir.
Okay, Mala Rizvi. So is it enough to go through or learn the lecture materials which you provided in the course for the exam? I think so, right? So the lecture materials, if you have assimilated very well, and also the tutorial material. Tutorial is an integral part of the lecture, right, or of this course, right? So if you have gone through that, assimilated it, right? Assimilated meaning that you have understood the concept, then you should be able to answer all the questions, right? So the questions will be based on the lectures, but it will also be application based, meaning that there will be questions which will require thinking, and it might not have been discussed in the lecture, but with the application of the concept of the lecture, you should be able to answer all the questions. Okay, is it fine, Mala?
Yes, sir.
Okay. Dhanush, from Rabi book itself, we can learn full custom of transistors and MOSFETs, sir. I think so. Rabi is a very good starting point. You can look into Rabi. Another book is Veste, right? WESTA, Veste. That is also a very good book for learning full custom of transistor for digital circuits, right? Not for analog circuits. For analog circuits, you have another kind of book, right? Razavi is generally suggested or recommended for analog circuit. For digital circuit at the transistor level, Rabi book and Veste books are the best. I wish to know everything from scratch. That's good. So I can come to know how these things are built up. For that, can you say some resources? So these books are very good, right? And as I know that there are YouTube lectures also for Rabi and so on. So look for those resources, the lectures on these topics, right? And also you should go learn a bit on MOSFETs and devices, right? For example, you should go through the book like Streetman, right? Streetman is a good book, starting book for transistors. You should go into that or look into that. Also, from how I should start projects in VLSI domain. So I have already explained that. Also, how to access the courses offered by Cadence Siemens Mentor Graphics. So please ask them. I'm not the right person to answer this question. Whether we should buy the software to access the courses or we can learn it without buying. That's why I'm giving you access to all the open source tools, right? See, all these tools from Cadence, Siemens, Mentor Graphics, those are license-based tools. Those are not freely available, right? And therefore, if you want to learn on your own, you should go for open source tools, which I have given the pointer to. Okay. So next question, Charan. About the ones counting, and the other question is about assignment, and other question is about the tutorial. So if you have lots of questions, you can ask through email, right? So, sorry?
Can you hear me, sir? Dhanush.
Dhanush, yes, Dhanush.
Sir, can you spell the book name for MOSFET?
For which? MOSFET, Streetman. STREET, Streetman and Banerjee.
Streetman and Banerjee.
Streetman, MAN.
Okay, sir.
As far I remember, the spelling is, I am typing on the chat box. Please recheck, Streetman. Then someone can correct it. Please look into Amazon. You will find this book, very popular. Okay. So Dhanush, okay. Charan, I was saying that if you have many questions, please ask through the forum. Okay.
Sir?
I will not, yes.
Just I need about ones counting. I mean, I had little doubt about it.
So ask the question.
Sir, in ones counting, we'll just count the number of ones in the, I mean, we'll just count the number of ones.
Right.
And we will compare it with the signatures.
Right.
Sir, but after counting the ones, like if we get 5 ones, then how the data will be stored in a room?
Sorry?
I mean, after counting, we got 5 ones in a data.
In an
how
adder.
I mean, in a signature, how it will be stored into the ROM? I mean,
ROM has got memory, right?
Sir, I mean, my doubt is that we got number 5. Again, the data is storing in the form of binary. Again, the 5 consists of 101. Again, it is, so we're getting again.
See, there are two things. One is the golden signature. Okay. Golden signature says that the response of the correct circuit is 5 ones, right? So 101 will be saved in the ROM. ROM, you understand, it is a read-only one memory, right? So while fabrication, you have put the number 101 in the memory of the ROM, right? The second thing is the test signature that will be computed for your circuit, right? That can be done as many times as you want, right? The tool will count the total number of ones that you are getting and put it in some accumulator or adder or anywhere, right? And then there will be a comparator between the golden signature, which is 101, which is hard coded in your circuit, and the test signature, which you computed in your circuit, which is 101. If these two are matching, you say that this circuit is good. If instead of 101, you got 100, that is 4 rather than 5, then it means that there was a fault in your circuit, right?
Sir, why we need to use ROM? I mean, it is somewhat slower than RAM. Why we can't use RAM? I mean, it also occupies less space compared to ROM.
See, you need not rewrite it, right? The random access memory is for rewriting, right? If you want to change it again, then it is fine, right? But ROM are typically used if you did not need to make change in the memory location. Here we are not required to make any change in memory location, so ROM is used.
Yes, sir. I mean, it present.
See, RAM is a static. If you have a RAM, it is volatile, right? You understand what is volatile?
Yes, sir.
So once you switch off your chip, the value 101 is gone, right?
Yes, sir.
So if you use a RAM, then you will not able to store it permanently. But here the golden signature is something which needs to be stored permanently, right?
So what will happen if you use a combination of both RAM and ROM instead of only ROM?
You can think of these things, right? Why will you want to have combination of both? Is it giving you any benefit?
Sometimes I think so, sir. I mean, in today's generation, in mobile companies, they are designing the memory such that the ROM is also sometimes used as RAM. I mean, some amount of ROM can be utilized as
See,
RAM.
you are taking a very specific case. See, basic purpose of storing golden signature is that golden signature is a signature of a good circuit, which was obtained using simulation. This is not going to change throughout the life of the product. You understand that?
Yes, sir.
Then why will you use a RAM? Is there any reason?
I mean, the only reason is speed, faster operation.
Why do you want to program it? What is the basic purpose of RAM? You want to program it, you want to change its value. And the biggest problem with that is that once you switch off the power, it goes away. From where will it know what is the value? How it will load again 101?
Yes, sir. It will be like
Yes.
demerit.
It will not be functional. This is not a demerit. It is not, you are losing the functionality, right? Okay, so think over it more carefully. You'll get the answer. I'll go to the next question. Okay, Avinash, sir, I have a question regarding assignment 9. So I got the solution of assignment 9. It is not yet released. After that, you can cast the question, right? Once the solution is released, then I can answer the question on the assignment. Harshit Reddy. Hello, sir. Present VLSI industry is replaced. The without human automation is possible. See, what will happen in future, I cannot say, but this trend has been continuing since the integrated circuit was invented, right? Since the time invention was done in 1960s, right? The automation is being increasing day by day, right? Or even year after year. Earlier, when we had only say 5 transistors or 10 transistors or 100 transistors, most of the things were done manually, right? But now we cannot live without the tools, right? For everything we need tools. For example, doing spice simulation, for doing circuit design, for doing logic synthesis, for everything we need tools, right? So the automation has been done, or has been automation is increasing year after year, right? And that the trend is still continuing, right? Now with the coming of machine learning, artificial intelligence, more of those kind of automation will be done. But that doesn't mean that all the designing will be done by the machines. I don't see that being done in next, say, 5 to 10 years at least, right? Yeah. So many things which can be automated, which are those things will be automated, right? But there are many things which are still require manual intervention, right? And that will be still be in the domain of human or manual work. Okay. Subhankar, Professor, if you are using scan cells, or you say replacing them instead of standard cells in scan design flow, does this mean we already use scan cell in reality, not the standard cell while designing? So Subhankar, scan cell is also a standard cell, right? What scan cell replacement is done is that it is replacing flip-flop, D flip-flop with another type of flip-flop, which is scan cell. And scan cell is also there in the library, right? So it is also a standard cell in the library, right? Is it fine, Subhankar?
Sir, yes, sir.
Okay. Harshit Reddy, I hope I have answered your question.
Oh, yes.
Okay. Avinash, hope I have answered your question. Okay. Bamshi Krishna. Okay. You have five questions. So I was calling your name many times. Okay. Anyway, so I want to know about how we do partitioning a high level block, right? So this is explained in the lecture. If you have any specific question, please ask. Bamshi.
Sir,
Yes.
Sir, I have regarding lecture, sir.
Yes.
Okay. Sir, even the third question I have one doubt, sir. Every flip
No,
flop
no.
is
First
converted
question. Let's go one by one.
Okay, sir. Okay, sir.
Already covered in the lecture. Do you have any further question from the lecture? You didn't understand any particular thing, then that I can take.
Sir, means we have multi-bit flip flop now, sir.
Yes.
Yes, sir. Sir, for that, how we will insert this scan flip flop for M-bit flip flop?
So you will replace each of the flip flop with the scan cell.
Multi-bit flip flop is itself a single entity, no, sir.
So for that you will not replace, right? You will not use it for scan chain.
Okay, okay, sir. Sir, this scan
See, there are many ways to deal with them, right? I'm not going into specific things, right?
Okay, sir. Sir,
yes.
inserting all these test structures within the chip,
yes.
These are used only in the testing stage itself. After production, there is no use of this test structures, no, sir. But the area is consumed a lot.
Yes. So that is a disadvantage.
Okay.
That is the disadvantage, but you have to live with it because it makes those things, for example, scan flip-flop instead of normal flip-flop, it is taking a additional area, also making scan chain is leading to more area and so on. So of course, these are taking area, but you have to live with it because if you don't do these things, your circuit will not be tested. Your customer will get wrong, faulty circuits, which is you don't want, right? So you have to live with it, right?
Okay, sir.
Okay, so let's. If you have any more question, Bamshi.
That's
okay,
it, sir.
So let's go to next. Anusha, sir, can you explain week 8 assignment question 8 and 9 about setup slack and pull slack? So I think the week 8 solution is not yet released, right? Is it released or not? Are you there, Anusha? So if there are numerical problems, I will upload the solution, a little more detailed solution of the numerical problems in the on the as a part of lecture notes, right? So if the problem question number 8 and 9 are numerical problems, then the answers to that those things will be covered by I'll be uploading them. Okay. Arjun. Can you tell us any sources to learn Python for FPGA? And also, can you discuss the growth of Python in VLSI design? See, TCL we have covered in this lecture. Python is also a scripting language which is used in VLSI design, right? So there are lots of resources available over internet, right? On Python, you can take help of those resources and um, learn on your own, right? Is there any specific question? Say Python for FPGA, I have no idea, right? What you are asking. I think all these things would be available over internet. I've never searched for myself, right? But at least you should learn one scripting language. TCL is one of the scripting language which was discussed in this course. Python is another language which is very useful. At least in area of AI and machine learning, lot of things are done in Python. And the third scripting language is Perl, P-E-R-L. Right? So if you want, you can learn this language also, right? So my take will be the first preference should be given to TCL, second to Python, and third to Perl, right? Okay. So let me go to the next question. Where we can find basics of VLSI design by Sneh Saurabh sir? Is it available online? Yes, it is available online on Amazon and Flipkart. Hello sir, present VLSI industry is replaced, or I have already taken this question. Okay, so thanks for answering, sir. Can you send the book name for analog devices? So the name is, as far I remember, the spelling may be wrong. It is Razavi, right? So you can take a note of this. Hello, sir. Present without okay. Sir, why we are not able to get yield 100% in manufacturing integrated chip? So see, there are lots of random things, right? Random things, meaning that when you do the fabrication, you do in a fabrication in a very controlled environment. Controlled environment meaning that the sizes of the dust particles are made very highly controlled, and number of particles which have sizes greater than some threshold, those are very controlled, right? I mean to say it is controlled, but those are not eliminated, right? There will still be some dust particle. We are not fabricating in vacuum, right? We cannot fabricate things in vacuum. We are fabricating in which in an environment in which human also can operate the machine and so on. So the environment in which the chips are fabricated, those are highly clean room. Those are known as clean room, but they are not 100% clean, right? Meaning that there will be some dust particles and other things in the environment. Additionally, there will be some tolerance, finite tolerance of the processes for process parameters. For example, if you say that my process parameter is say 100°C furnace temperature, right? Now, it is not possible to maintain exactly 800°C furnace temperature. It will be 800°C plus minus 2 degrees. There will be finite tolerances. Because of these finite tolerances, and also because of randomness in the environment, you will have some random defects in our chip, right? And therefore the yield cannot be 100%. Typically, it is for not advanced, for matured processes, for example, 65 nanometer, 45 nanometer, those will be higher than 95%, 98% or so, right? It will be very high, but not 100%. Okay. So I think I have answered all the questions.
Hello, sir. Am I
Yes.
audible?
Yes.
This is Avinash as well.
Yes. Please ask your question.
Okay, so my question was in regarding assignment 9 and whose answer was already recorded because its due was 27th September. So
Which
can I ask?
Assignment 9, right?
Yeah.
So the solution for that is already published.
Yeah, sir.
Okay. So what is your question?
My question is in question number 8, it was asked that from the perspective of design for test DFT, which of the following statement best describe a test vector?
Please ask this over the forum. I'll answer that. I'll see the question paper, then only I can answer.
Okay.
I don't have question paper in front of me at this point of time. It will be not correct to give an answer at this point of time. Please ask your question on the forum.
So one more thing that as the NPTEL launched the lab workshop for some of its courses which needs hands-on training. So is there any lab workshop for this RTL course?
I didn't get your question. Can you repeat it?
I'm asking that as we know that NPTEL launches lab workshop for some of its courses which needs hands-on training. So is there be any lab workshop for this RTL?
Not planned at this point of time.
Okay.
Yeah.
Thank you.
Okay.
Hi, sir.
Yes.
This is Anish. So actually, I have one small question regarding how bus is designed physically, like on die. Like,
I'm
is it
not able
like,
to understand your question.
like there is a bus, right? Suppose like we have BIST, built-in self-test. In
Right.
that on die, you have a built-in self-test module and the circuit under test. So we have an interconnect between that, like a bus is there, right? Yeah, like how that bus will be like designed. Is it like a group of like tracks, or is it a complete single track? How it is designed on?
So it
die?
will have to be different tracks or different wires, right? Otherwise, it will be shorted, right?
Yeah, then that will be a lot of overlapping capacitance, right?
It can lead to those things have to be taken care into account.
Okay, will that be only overlapping capacitance, or it can be considered as lateral capacitance as well?
It depends on how you have done the layout, right? Unless
Suppose
and until you,
parallelly. Suppose parallelly.
so then you know the answer, right? If it is parallel, then what kind of capacitance will be there? It is covered in the course.
Overlap, but
no, it will not be overlap. It will be lateral. See, overlap capacitance happens when one track is running over the other, right? Something like this. Lateral capacitance is parallel, like this.
Okay. On top, if it is, then it is
Yes,
overlap.
then it is overlap.
Okay. And also, is there any difference between this bus and the interface concept that that is in SV, system Verilog?
First, tell me what is definition of a bus. Tell me the definition of interface. Then I can tell you.
So bus is basically between, like, suppose if you are using a language called Verilog for design and test, and different language like SV, then we can normally use a bus, because both are different
There is
languages.
no concept of bus in Verilog. There is a concept of vector, right?
Yeah, vector.
Vector and scalar, right?
Yes.
In system Verilog, you have another kind of data structure or another kind of entity which is known as interface. And
Yes.
interface is similar to a class in C++. You understand what is a class?
Yes, sir.
Right. So the interface that is there in system Verilog is It is much richer in construct and it is much richer in behavior, right? So you can do a lot of things with interfaces, right?
Yes.
Okay, so I'm not going into system Verilog in this course, so let's not go further into it.
Okay. And in iCaris, if you want to execute any
Sorry?
SV test bench, is that possible, sir?
What is your question?
Like we can simulate the Verilog files, right? Like in iCaris, is there any such command for
The tool, right? These things are not for me to answer. You should explore, right? Then only you will learn. If you
Yes,
ask
sir,
it
I
someone
tried
else,
with
you are not learning.
SV.sv, but it didn't work. So
it might not be supporting. I have no idea.
okay. Thank you, sir.
Yeah. Okay. So see, this question answer can go on till very long, right? So we have already crossed the time. It was till 3 o'clock. Let me see one or two more questions and then we can conclude. The reduce in NM can cause various losses. No, sir. How they are handling, sir? So Dhanush, can you explain what you are trying to say here?
Sir, I mean nanometer, sir.
What is the question?
Reducing nanometer technologies nowadays are coming now, sir. Like introducing FinFET, that like devices.
So what is your question?
In that, how their channel is optimized and using the losses.
So you have to go into devices to understand those things.
Okay, sir.
Okay. Vinayak, sir, in a given wafer at the time of binning, the speed grades are different. How this happens? This happens because of the process variation, right? So when we manufacture a chip, right? We manufacture on a wafer. Now this wafer will contain hundreds of different die, right? One wafer can have hundreds of die. Now, if we look into the wafer is a kind of a circle, and if you think of die one at one end and at diametrically opposite end, they are very far apart. Now, will the property of both the die be the same, meaning the property of the devices or transistors at the both end of the wafer, will it be the same? Typically unlikely. Why? Because of process-induced variation. Why that can happen? Because when you are doing fabrication, you are doing various kind of process steps. For example, oxidation, ion implantation, and so on, right? And the temperature at one end of the wafer and the other end of the wafer may not be exactly same. It may be slight variation, maybe say 0.1 centigrade difference. And because of that small difference in temperature, there can be more oxidation in one area, less oxidation in one area, more ion implantation in one area and less ion implantation in other area. The thickness of the interconnect can be more in one area and so on. So because of that, there can be variations in the properties of the transistors that we have. And that's why we do corner-based analysis. So if you look into the lectures of STA, you know that we have done corner-based analysis. We talked about worst corner, best corner, slow corner, fast corner, and so on, right? So why these corners are coming? These corners are coming because of variations in manufacturing process, right? And therefore, the properties can be different and therefore the speeds can be different for different dies on the same wafer. Okay, Vinayak? Oh. Next question, Dhanush. What should we take next after this course, and do you organize an other course in coming months? So I don't think I am planning anything in the next few months, right? But I will put some lecture materials which might not be covered in this NPTEL lectures. Those will be more basic kind of thing on my channel, YouTube channel. You may look into that if you want, right? which course we should take after this course, I will say that rather than taking different courses, you should run the tools, right? So you should run the tools and do experiments on your own. Try to build circuits with different kind of functionalities. Do simulations. See the result. Do placement routing. See the result, and so on. Right. So gain hands-on experience. That is more important. If you are able to get internship, that will be very, very good, right? If not, do these things on your own and learn and develop your skill set. Okay.
Sir, Vinayak here.
Yes. Vinayak.
Thanks for the query. But on the same lines, I have a question. Is it possible to estimate in a given wafer the speed grades, how much I'm going to get, like 45 nanoseconds, 35 nanoseconds, and 50 nanoseconds for a memory SRAM?
So
is there estimate?
We typically what we do is that inside our chip, we also have monitoring circuit, right? So we have, for example, a simple monitoring circuit will be a ring oscillator, right? Now, if you have a ring oscillator and you run it, you can get the frequency out of it, and it will tell you some estimate of whether it was manufactured in the slow corner or in the fast corner, right? So similarly, there are other kinds of more sophisticated circuits which are kept as a monitoring circuit in our chip or inside our chip, which helps us get the information that what is the speed grade of the manufactured chip. Okay.
Okay. Thank you, sir.
Any other question? Okay, so let me see. Once glitch, sir, what are we doing overall physically? So Shubhankar, please explain your question. I'm not able to understand.
Sir, the fact is that in clock getter or say clock getting, what we were doing that is it we are saying that the clock cycle, the negative part of it, we are means we want to diminish that negative part from the G clock waveform.
We want to have either no clock or a clock of complete clock cycle.
Okay, not the broken one.
Not a broken, because a broken can cause a setup violation in the next stage.
Okay, and this means that integrated clock getter. So we are from that LQ part, we are taking that part which has been
which is glitch free.
Glitch free means which has been we are adding that part which was taken down by the negative part of clock cycle from the LQ.
That was removed from the negative part.
Yes.
Right.
Okay.
Okay. So next question, channel name, sir. So you have to search by name, you will get the channel name. Okay. Arjun, I wanted to express my heartfelt appreciation for excellent book on VLSI design flow. Your book has been invaluable resource in electronics department and has greatly enhanced my understanding of this complex field. Your clear and accessible explanations have made a significant on my learning journey, and I'm truly grateful for expertise and dedication to advancing VLSI design. Thank you, sir, for your outstanding contribution. So thanks a lot, Arjun, for your kind words. So these are the words which keeps me going, right? Thank you very much. Okay, so is there any more questions? I'm not sure, Shubhankar, whether we'll meet again. I'm not sure. You can ask your question over forum, right? So about the exam, most of the questions were related to exam on that were there. So I've answered the pattern, right? So let me take some more time on the questions that were asked over by filling the form. So even though students may not be there, I'll take their question. So the first question is from Nilay. So he's saying that I want to know whether the tutorial section that was covered is in this course will be covered in the exam, right? So yes, see, it is difficult to differentiate what is theory, what is practical. I will suggest that don't neglect the tutorial part. Question may not be directly related to tutorial, but if you understand the tutorial part, you will be able to answer the question of the other parts also much better. So I'll suggest that the tutorial part is an integral part of this course, and don't leave it for your exam just because that question may not be there from directly from there. Okay, that is one thing about the tutorial. Let me take the another question. Okay, so that is related to Jayasurya, is about taking some part-time role. So that is not with me. I'm not the right person to answer that question. Then industry support, right? Again, that is not Nitin. So that question. So he's asking that if there is some internship available for 1% topper or 5% topper. So I don't think so. There is an internship available. Then third and question from Lata is there that it is about my book, right? So she's asking that is there a online platform where tools can be run? So I don't think so, but whole purpose of running this tutorial was that you will be able to install these tools on your own and able to run those tools, right? So I will suggest that you should go through the exercise of installing the tool. It will give you a lot of confidence, right? Because see, if you know Unix, it will really be helpful in your VLSI career, because anywhere you go, any VLSI industry or any company, especially for digital circuit or digital design, Unix is everywhere the platform which is used, right? So if you are comfortable with installing the things and are comfortable with the Unix command, it will be very useful in your VLSI career, right? So some time in installing the tools. Okay. Then there was some question on from Shiva. That is very particular question. I will ask him to ask that question on the forum. Probably there I can answer, because it is something related not covered in the class, in the lectures. And then from Praful, you are not able to get previous year question paper. So there was no exam last year, right? This is the first time this course is launched. That's why you cannot find, right? So how the question paper will be in the final exam? So as I said, it will be on the pattern of the assignment, right? It will be a similar MCQ based questions, right? You have to give the answer which is most appropriate out of 4. Please provide a step-by-step solution for the problems. Okay, so for numerical problems, I'll provide the answers once the answers are disclosed on the platform. Okay, so from HS Sanjay, could you please share a detailed view of SOC, chip designer, design engineer, and to that of ASIC engineer in the VLSI industry? So I'm not able to understand this question. So HS Sanjay, if you are there, are you there? I don't think so. He is there. Okay, so let me go to the. So from Patil, Mayur Patil, question was related to internship, and then from okay. So I've covered all the questions which were there asked on that. Okay. So last call, if you have any question, if you want to tell something, please feel free to write in the chat box or tell something. Okay. If nothing, then that's the end, right? So okay, so one question is there, why Unix, right? So everywhere in the VLSI industry, people use Unix, right? So first of all, Unix is free, right? That is one of the biggest things. The security and the issues are less in Unix, right? And people are comfortable using the Unix environment, right? So Unix is de facto the platform for the VLSI industry. So you should be answering. So you should try to learn the commands of Unix. Okay. So thank you all. Thank you all the participants for your making this session live, alive, right? Yeah, if there is some question, I think someone was asking something. Yes.
Is there any role for assembly language, sir, in VLSI?
Assembly language. So when you do design processors and those things, I think there are some use of those assembly language in that area.
Okay, sir.
Okay. Okay, so I think there are no further questions. So I will end this session at this point of time. Thank you all the participants for making this live session alive, right, for all of us, and also being so active on the forum where I see lots of questions and I give answers to them. So all the best for your exam.